Hello, in this video we are going to sketch the graph of a quadratic function given in standard form. The five main features of this curve that we are going to find to sketch it are the concavity, the axis-intercept, the axis of symmetry, and the vertex. And the function we are going to use in this example is called f of x, and it's defined by x squared minus 2x minus 3. So the first thing we are going to look at is the concavity. So we are looking at whether the parabola looks like a smile or a sad mouth. So if we are talking about something like this or like this, and this is determined by the main coefficient of the definition of f. So by the coefficient that is multiplying x squared. Usually we call it a, and in this case a is equal to 1, which is greater than 0. So this implies that the concavity is positive. To find the y-intercept of any function, what we want to know is what is the value of the function when x is 0. So we want to evaluate the function at 0. And when we do that, everything that has a variable x is going to be 0. So we just get -3. So this means that the coordinates of the y-intercept are 0, 3. Now to find the x-intercept or intercepts, we don't know. We know that we are going to be solving when the function is equal to 0. So we are going to be solving a quadratic equation. So we want to know when x squared minus 2x minus 3 is equal to 0. And we know that quadratic equations can have 0 solutions, 1 solution, or 2. So let's see what is the case here. We can solve this in different ways. We could, for instance, apply the quadratic formula if we wanted to. We can also try to factorize. We will be trying to find two numbers, p and q, such that when we sum them, the result is -2. And when we multiply them, the result is -3. So that will work if we multiply -3 times 1, and if we do -3 plus 1. So that means we can use that to split the middle term. So x squared plus x minus 3x minus 3 equal to 0 is what we are trying to solve. So this means if we take common factor between the first and second term, x, and between the third and fourth, -3, we get that we can factorize this expression as x minus 3 times x plus 1 is equal to 0. So this means by the non-factor law that the expression is going to be equal to 0 either when x is equal to 3 or when x is equal to -1. So this means that the coordinates of the x-intercepts are 3, 0 and -1, 0. I made a bit of space because we need it for the sketch, and also I'm going to correct here a very dumb mistake. For the y-intercept, the coordinates are 0, -3. Sorry about that. So with the information we have so far, I want to actually start looking at how this sketch is going to look like. So I'm going to need to have a pair of axes. Let me see here. Yes, so how about this? Maybe it's too big, we'll see in a second. So let's think about which values we need to include here, which scale would be a good one for us. Well, we need the point -3 in the y-axis, and then in the x-axis we already have the point -1 and 3. So I think I'm going to go for saying that 1 square represents 1 unit in both the vertical and horizontal direction. And now I'm going to add the points we know so far. We have the y-intercept at 0, -3. So I'm going to mark here the point. I'm going to write the value of the point in the y-axis over there. And even more, I'm going to make a note here that this is the y-intercept. If I want to have a nice, complete graph, all of this is required. Now let's move to the x-intercepts. We have one of them at -1, 0, so I'm going to mark the point at -1 in the x-axis. This is one of the x-intercepts. And I'm going to also need the point at 3. This is the other one. And we know that the concavity is positive, so we have an idea of how this parabola is going to look like. Okay, this is a very rough sketch. I'm just going to do it for 1 second and then erase it. But we know that the parabola is going to look like something like this, because it has to be a happy parabola and it has to go through the points that they have marked. So this is a very rough idea of how the parabola is going to look like, but it's going to be useful for us to think about where is the axis of symmetry. The axis of symmetry is a vertical line that has the property that if we were able to fold the parabola by there, then we will get the two branches to coincide. So we're going to have two symmetric bits on the sides here. So yeah, where is it then? Well, it has to be halfway between the x-intercepts. And what I'm saying is when I look at the point in the x-axis at -1 and the point in the x-axis at 3, I know that when I fold the parabola, those points have to coincide. So I have to fold the parabola halfway between them. So let's see, between -1 and 3, there are 4 steps. Yeah, here, let me mark it. 4 steps. And I want to know what is halfway. So I need to look what is 2 steps. So that's going to be exactly at the point 1. So what I'm doing over here is finding the midpoint of the x-intercepts. So let me call this point M. And this point we find it by summing the coordinates and divided by 2. So -1 plus 3 divided by 2 is the x-coordinate and 0 is the y. So this is the point at 1, 0. And what I claim is that the axis of symmetry is the vertical line going through that point. So let's see if you can imagine it over here. It's going to be here, a vertical line going through the point M. Well, if this is a vertical line, then it means we know how to write the formula for it. It's going to be x equals something because it's a vertical line, and because it goes through the point 1, 0, this is x equals 1. So here at x equals 1, that is the equation of the axis of symmetry. Let me erase my attempt at the parabola that I have here in sky blue. This is not very good at just, it was a good visual aid for us, I think. And now it's gone. Okay, we're almost done. We are missing the vertex. So the vertex in this case is going to be a minimum, and it's the turning point of our graph. And it has been the turning point. It belongs at the same time as to the graph and to the axis of symmetry. So that means that we already know the x-coordinate. The x-coordinate of the vertex is going to be 1. And the y-coordinate, well, that's going to be the image of 1 under the function. So, one more time, we know that the vertex is in the axis of symmetry. That's it's one of the points where we fold the parabola. So we know that the x-coordinate is 1 because all the points in the axis of symmetry have x coordinate 1. And now we know it's in the function, so the y coordinate we can find it applying the formula. So let's do that. The result of applying the function f to 1 is going to be 1 squared minus 2 times 1 minus 3. And this is 1 minus 2 minus 3, so negative 4. So the coordinates of the vertex are 1, negative 4. Let me find this point in the picture. Here it is. So this is the vertex, and the coordinates are 1, negative 4. And when I have the vertex, I like to just, because I know it's a minimum, make this little shape over there. We know that the vertex is, the parabola is going to go through it. So these were the 5 main features we have to find, and this is enough for us to sketch the graph of the parabola. I'm going to begin by sketching the branch that is on the negative side of x. Let's see, it doesn't have to look perfect, but it has to go through the points that we know it goes. It has to have some kind of symmetry. So for instance, here we have the point negative 3 in the y-axis, and we're going to also have to have the point negative 3 one step to the other side. So this is the point 2, negative 3. We know the parabola has to go through there by symmetry. So let's do that. And then it has to go also to the other x intercept, and I keep going up. So this is a parabola with positive concavity. It has the axis intercepts that we found. We also sketched the, sorry, not the axis, the axis intercept. It has the axis of symmetry that we sketch here as well with equation x equals 1. It has a vertex, which is a minimum, and we found it over there. We make sure that we make something smooth going through the vertex. So it's not going to look like something sharp. It's going to look like something rounded where I turn. That's how parabolas look like. And I make sure that I made my parabola at least as big as my axes are. So I don't stop my parabola like down here. I go all the way up as much as my axes go. That's the correct way of doing it. And the last thing that I'm going to do, I have labels for all the features. I'm going to add this is y equals f of x. And we are done with our sketch.